Nathan can watch it. Oh, what was your favorite video? The TED Talk, the one we watched in class. That was a good one. How about the ones we didn't watch in class? Did you guys get those done yesterday? Yeah. With the breakdown of the catalytic converter, or the other one with just the catalyst. Let's talk first about the catalytic converter one, because that's kind of cool, that dismantle show or whatever, where they break down that. The catalytic converter is basically what prevents cars from releasing more harmful gases and stuff like that. Basically, the catalytic converter is a small part under the car, but it has a surface area of like 3 football fields, right? So it has the ability to like cause unspent fuel, as well as some other byproducts, carbon monoxide and stuff like that. That catalyst allows them to form, less toxic things. One thing it doesn't allow is to get rid of the carbon dioxide, unfortunately, which is the greenhouse gas, which blah, 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 right? We know that this gas is affecting our, what is it? Do we call it global warming anymore? What do we call it now? Environmental something or other? In climate change, right? Yeah. What is the key thing though about that catalytic converter? What is the problem with it? Also dealing with reaction rate, yeah. You got it. It needs warming up. So in the first 5 miles, it is not effective. It is not as effective as it could be. How many of you work? Nobody here works. Oh, okay. And how many miles do you live away from your work? 15 minutes, which is? He is correct. 15 minutes is a quarter of an hour. Do we have distance at all? Is it within 10 miles? 4 miles, and it takes him 15. Do you ride your big wheel to work?
How many miles is 15 going?
Probably about 10 to maybe 7 to 10. If you're going 60 miles an hour, you're going to travel. Keystone's about 60 miles per hour. If you speed. So I live up in Westfield, and I live it's actually 10 miles from point to point. So it's closer to 15 miles, but it takes me about 17 minutes to get here. Now, the first 5 miles of that, obviously the catalytic converter is not working its full potential. As I go home, if I don't do anything else, so out of that travel time, right, 10 miles out of the 30 miles, or 1/3 of it, is not as effective because the catalytic converter is not as hot, right? If you live within 5 miles of your work, then your catalytic converter never gets warm enough to actually be as effective as it could be. It's a great thing, but it does have those limitations. And we know that temperature is a huge factor when determining reaction rate, because we said for every 10 degrees, what happens to the rate normally? It gets bigger, has been said in class. Does anybody remember by what factor? Every 10 degrees, it doubles. It doubles. So the catalytic converter video was fun. You guys saw the one where I blew up the flower. The catalyst one was in there. Was Genie in the Bottle in there? There's some other videos that sometimes I show on this. I was just wondering which ones were on this one. Don't think that one was on there. That's possible. But yeah, hopefully we got enough of the good ones. Yes. I think there's like toilet paper back there on the table behind the kid in the mask. What's his name? Gavin. I don't know. Gavin like came and surprised everybody. He's like, all of a sudden I'm in person. What? Right? Yeah. Like I didn't even recognize Brody whenever I thought he used to wear glasses. But if you're not looking at anything, you don't need them. You're not looking at anything right now. Reading wise. Oh my gosh, Leo. Leo's being Leo. All right, if we take a look here. Here is a quick and dirty refresh of reaction rates. Fastest at the start, more reactants at the start. As we go through, what happens? Reactant concentration decreases and product concentration increases. So it slows down, right? How many of you have a date for the prom now? People are it's still Owen still got his date. I'm glad to see that nothing happened over spring break to put that into the possibility of a cancellation or anything. But as time gets closer and closer and closer, there's going to be more couples formed and less people that don't have dates. So just keep that in mind. In order for a reaction to occur, particles must collide with proper orientation. We did this with our hands and a handshake and stuff like that. In order for the particles must also have the minimum amount of energy required. We call this the energy of activation energy. And what that does is that makes the activated complex or the transition state. Now, at that point, it is a 50-50 as to whether or not it goes to completion or it goes back to reactants. Here are the factors that affect reaction rate. We said a catalyst basically forms a temporary bond and basically allows the electrons to kind of maneuver around and then cause the reaction to occur. What this does is it forms like that placeholder. It allows it to not require as much energy. We use this in the case of the finding a date to the prom as, hey, so-and-so's sister likes you, ask her, and then you don't have to put much energy in except for going to so-and-so. You don't have to sit there and ask 30 people or whatever it is, right? You don't even have to do the big promposal or whatever. That's always weird when that happens. Like kids are like, hey, can I hide this ridiculous amount of candy and stuffed animals under your back table? And then I want, like, we used to have these pull down boards. Can I write something silly on the back of your board? And then you release it. And like, it's like this big thing. Or one kind, like, during your PowerPoint, could you put this slide in? Like all of the crazy effort and energy required. Actually, that's never happened. Yeah, never got a no on the promposals for Mr. Jackson's class. But yeah, they knew, right? But the catalyst basically reduces the energy requirement. And the cool thing is catalysts are not used up, so they can be reused. In your body, catalysts are enzymes. For example, in your mouth, there is an enzyme that breaks down starches even before you get it to your stomach. Does anybody remember what that one is from biology last year?
Salivary amylase.
It's in the salivary, yep. Both are wrong, but it's right.
Is it amylase?
Amylase. Amylase, you probably heard of that. Again, you know this because it ends in ASE from your biology years. What is the one that breaks apart the double helix?
Helicase.
Helicase. Yep, hex. Yeah. So these are all enzymes. The good thing is that they're not used up, so your body does not have to use precious resources in order to rebuild the supply of these, right? What's that? It's basically a catalyst that your body's created. It's a chemical compound. How do they not get used up? That's a good point. Basically, they don't form a permanent bond. So it's not like something coming in and bonding and then part of it breaking off. It maintains its same structure and it only forms a temporary place for things to bond. How does it what? It lowers the energy requirement. So if the compounds, our body is already hot, right? And these chemical compounds have a certain amount of energy. So they may not undergo this change unless the enzyme is there. So they're going under their normal things, right? And they're not reacting. But the enzyme being there allows them, because it does lower the energy requirement, allows them to actually react. But for example, what is the enzyme that allows for DNA to replicate? Polymerase, right? It builds a polymer, multiple chains together, right? So ACE tells you that it's an enzyme. Polymerase tells you that it basically is a construction enzyme. There's two, one for the 5' to 3', and one for the 3' to 5'. Do you remember both? Polymerase 1 and polymerase 3. You don't remember those? Is Miss Smiley the substitute? So you guys were the hellions that
Okay. Yeah.
that caused her probably to cry every night. I'm assuming because you guys are so mean.
Teachers cry a lot. More when I know some parts of it.
Are you guys the bad class?
I was in the.
You guys are the baddies?
We have one fight for that. We are
And any questions on enzymes? I'm just finding out that this is the worst. Like the sophomore class is like the creator of the creator of tears. Is that maybe that's your guys' class title? The creator of tears. So if we take a look, these are the other factors affecting it. Temperature. If you increase temperature, the rate increases. We said for about every 10 degrees, it doubles. The way this happens is if you increase temperature, the particles are moving faster, so there's going to be more collisions, and they're going to have more overall kinetic energy because that's what temperature is. Concentration means we have more particles, higher concentration, more particles, more collisions, right? It's like running down the hallway right now or running down the hallway at 2, whatever it is. Surface area, right? If I grabbed a hold of Leo and I tossed him, I could probably only hit 1 or 2 people with him. If we cut him up into little pieces, right? Then he would collide more. Like if I had a bucket of if I had a bucket or something like that, we could have him collide with more people. No, definitely we know by grinding up something or cutting something up into smaller pieces, we increase the surface area and we get more collisions. Right. Let's like if you have a big block of cheese and you're trying to make nachos, that's not going to be cool. But if you take and what is it called? Grate the cheese and then spread it all over, it's going to melt nicely, right? Yeah. You have a huge plate of nachos and you just put one big block of cheese in there and put it in the microwave for 40 seconds. That's disgusting. That's not good. What's that? Silently judging the nachos. You blocked nachos. All right, so let's take a look. If we take a look at a progress chart for these guys. This is just a very basic one. Here we have concentration and molarity. We can use brackets for concentration. I'm going to start with the reactants. They have a high concentration at the start, and then they have a sharp decline, and then eventually they will level off. This is because the reaction rate is faster. Here is our independent variable time. Fast and then slow. Now our products start at 0 probably, and they will go up and then boom, they will level off as well. And here's something we might not have talked about before. We would call this stage equilibrium. Notice that all of my reactants did not go away. Another thing you might see is that this reaction becomes what we know as reversible. So let's just say, and I'm just going to make this very simple, A becomes B, whatever. This could be a conglomeration and stuff. Well, in reality, some reactions will allow B to become A. You could see this, for example, if I have H2O, I know by using electrolysis, I can break that down into hydrogen and oxygen. Or I know that I can take hydrogen in the presence of oxygen and put a flame there, and I will get H2O, right? This is the reversible reaction. I can go either way. Some reactions do that on their own, and they reach a part where they have what's called equilibrium. Reactants are becoming products, and products are becoming reactants simultaneously. But this is how a reaction could become irreversible. Or not, yeah, reversible, reversible. All right. Is this your groups? We already have the answers to 10. And let's watch this, and I'm gonna mute it because I can't remember if it's the one with annoying voice or not. What's that? I think the genie in the bottle one, like she's like, he's got this New York accent. Pretty thick. Let's see if I can find that one. There used to be this song, that's where you used to play it. I'm a genie in a bottle, baby. You guys know this song? You think you've heard the genie in the bottle song? Wait a second here. You're questioning my.
I've heard it.
Amari's heard it. You're questioning my singing ability?
Whoa.
Watch it, you. My memory. Let's show the genie one real quick. And I know that these videos do not go great over this internet. So I will do this quickly. No. Emma just cares about the Genie in the Bottle song. I think it's Christina Aguilera. Oh, you took it up?
So what, were you expecting a genie or something? Get out of here.
Yeah, there's that New York. Get out of here, kids.
Mystery class. Okay, what made the spooky cloud appear? 2 clues. 1, in the flask, hydrogen peroxide. 2, in the tea bag, manganese dioxide. Okay, you know what hydrogen peroxide is, right? Right. You know why it fizzes when you put it on cuts?
Does anybody know the enzyme that causes it to fizz when you put it on cut? You know it has to end in what? Ace. Come on. Peroxidase. How easy is that, right?
Because there's a natural enzyme catalyst in your blood that speeds up how fast hydrogen peroxide decomposes into water vapor and oxygen. And
That's a definite dub, isn't it?
manganese dioxide? Yep, even a better catalyst. So, what made the cloud appear? Okay, let's go behind the scenes. Here's my flask of hydrogen peroxide. Keep thinking catalyst reaction. Now, sodium phosphate.
So we have catalysts which speed up a reaction. She just tossed sodium phosphate in.
Whoa, it's sudden death.
And what happened to the reaction after she tossed sodium phosphate in there? Stop the reaction. If a catalyst speeds up a reaction, what's the term for something that stops the reaction? Inhibitor.
Note the color change. Sodium phosphate, the great inhibitor. Why does that happen?
Very cool. We just did. Dun, 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 dun. Oh, did I show you guys this? This is a teacher who used to teach here. Doesn't teach here anymore.
Welcome to physics.
Oh my gosh! Oh my god!
He actually teaches up at Westfield. He did that at Westfield. What's that? That was his last day. Here it is in slow motion. I like to show this one to him because his face. His face right here, like when this happens, it's like, oh no. He just puts so much in there that, yeah. Oh no. That would not be good. But you can see how much you put in there because the table is still on fire. So that's definitely a concentration problem. Reaction occurred way too fast, and apparently the bottle was probably also weakened somehow. Yes. Last one I want to show is the Catalyst movie, which many of you probably saw this over yesterday or Friday, if you were trying to not bother with Monday. But basically, I want to show you this. I think I'm going to mute her. So basically, this is a catalyst to form ammonia. Ammonia is a very important chemical for the production of ammonium nitrate and ammonium hydroxide and different stuff like that. Because that can be used as fertilizer. Without fertilizers, we would not be able to maintain the population of the world that we have today. There would be starvation and stuff like that. Yeah, right. So a catalyst would be one way. As you can see, it's causing temporary bonds with the nitrogen right here. That's a platinum, probably a platinum piece. You can see right here, these are impurities. So something bound to the platinum, maybe an oxide or something like that. But it causes a temporary bond with these. This is really an over exaggeration, but what allows that to occur then is electrons to move around and basically form structures that are more, what's the word? More stable compounds. What we really want to look at today is called an energy diagram. So if we take a look here, is there any way I can get that to not bring that up? Oh, I can move it. Hey. So if we take a look here, this is the amount of energy that the reactants have. We know this as the H of the reactants. Remember H, the enthalpy for the last semester. I didn't have you last semester, did I? Yeah, so he should have covered this. H is the enthalpy of the H of R. This is the enthalpy of the reactants. This is how much energy they have. This is the energy of the products over here. Do the products have more or less energy than the reactants?
Less.
So this means that the reactants have lost energy during the reaction according to the products. Products have less energy than reactants. What is delta H here?
Negative.
It's a change in heat or enthalpy. What would it be, positive or negative in this case? I muted these guys at home. Let's turn them back on. Delta H, yes, it's gone down. The products have less energy, so energy has been lost from the system, right? So delta H is negative. So this is the potential energy of the reactants, potential energy of the products. This is an uncatalyzed reaction. So this energy from the reactants energy up to here is what we call the activation energy, or E of A. If particular reactants have that activation energy, then they can undergo the reaction, form the transition state or the activated complex, whatever you want to call it, and then possibly form the products. If we had a catalyst,
to occur because of the
if we had a
a
catalyst,
greater number of reacting molecules.
it lowers the activation energy. So note, the energy of activation is now less required. Did it change delta H? No. Delta H, the energy of the products and the energy of the reactants is still the same. So delta H has not changed on that.
Have enough energy to form products. Notice that the initial and final potential.
Does she do anything else? No. Okay. Cool. So let's open up to page 6 and take a look at some of these. 666. Yeah, we kind of are stepping in this a little bit easy. We decided to go not math today. Well, light math, I should say. So here is our energy in kilojoules. This is the progress of the reaction or time. This is the energy requirements or changes. So is this endo or exothermic? Exo. What letter represents the activation energy of a forward reaction? A. Here is the energy of the reactants. Here's the energy of the activated complex. What letter represents delta H for the reaction?
D.
D is correct. Here's the energy of the reactants. Here's the energy of the products. What does C represent? Energy of the products. What is the activation energy of the reverse reaction? So if we were making C into A and B, E would be required. Because we start here and we're going over here, we need that. What does B represent? Energy of the reactants. And how much energy does the activated complex have?
11 kilojoules.
11 kilojoules. If we were going with the theme of this, we also could say C plus E or B plus A, right? Good, good. If I were to draw a catalyst, could I draw it this way? Would that be appropriate for a catalyst dotted line?
No.
No, the catalyst always has to take less energy. What could this be the line for?
An inhibitor.
Yeah, some type of inhibitor, right? Inhibitors can work in many different ways. For example, you probably use like aspirin as a pain inhibitor, right? Doesn't necessarily prevent all the reactions from occurring, but it lessens them, right? A binding site inhibitor. All right, so you should be able to answer these questions. And for this, it may be looking for a number. You have the number off to the side. Let's do one of the drawings. Mask is hurting my ears. See if I can make this focused a little bit more. Is it better or worse? A or B? Brody's got his glasses on. Better? Not great. Is this great? I think that's the best, isn't it? All
Yeah,
right. Good, good. So if we take a look, it wants us to plot the energy diagram. This first one, I'm going to do this first one. It's the easiest, obviously. I think you should be able to get through the rest. This stuff isn't that hard. There's just a few rules to remember. Potential energy of reactants is 250. Here's 100, 250. Complex is 350. Here's 300. Here's 350. That's the top of my arc. And potential energy of products is 300. Everybody okay out there? So we're going to come along. We need to get this amount of energy and we form this product. Endothermic or exothermic? Endothermic, because we've gained energy from reactants to products. What is delta H equal to? 50 from here to here. What is the energy of activation? What's the E of A? What's the activation energy? Louder? That's the energy the activated complex would have.
Would it be 100?
It'll be 100. We already have 250. We have to get up to 350. So we add 100 to it. Yeah, I want to make sure that I get that question because that's a hard one, right? You're trying to get the energy of the activated complex. And then we got the delta H. You could give the energy of here. You could make a dotted line to show the other thing. The catalyst, what catalyst to do it. Questions there? No, all right, let's take a look then. I got one last thing for you before I let you guys go. Dun, 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 dun. Dun, 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 dun. How's that look? Looks good. All right. No. So 200 milliliter beaker, watch glass. Here I've got a substance called MnO2, either manganese 4 oxide or also commonly called a manganese dioxide, which is not the naming system we are used to. We would call this manganese 4 oxide. What's the formula for it?
MnO2.
MnO2. All right. So here I've got 3% hydrogen peroxide, which you're used to probably. This is the kind you put on a cut. And what it will do is basically cause the cell wall of the bacteria to oxidize. It will not cause this for your cells because your cells have what in them? Peroxidase, which is the enzyme that breaks down it, right? Bacteria, a lot of bacteria do not have that. And I'm not sure, maybe it's like a gram negative, gram positive thing. You guys remember gram negative, gram positive from your days in biology? Yeah. Okay, cool. Would you guys, I guess COVID last year just got you guys like, oh. So these guys can't take AP Bio already, right? Hopefully you guys aren't planning on being doctors. Otherwise you have to, it basically limited your career opportunities. That's probably pretty heavy, right? Yeah. Yeah. This, you remember the Burple commercial? Was that only for the people here on hybrid? Purple, purple, purple. Did we ever do the Burple commercial? Period 5-6 must be so much cooler than me. No, I'm just kidding. They do all this other stuff. It's 7 minutes longer, isn't it? Of course you are. Doesn't mean you guys are the coolest class. You guys are the class that makes me feel like I'm teaching a normal year again.
We need to amp up the-
A period 5-6.
What do we need to
It's just off the hook.
do?
It's got Ian Fisher in there. Mia and Anna Reynolds. Rivas. Yeah, you guys need to amp up the cool factor. That's not all of it. Leo being Leo. And actually, yeah, she's up the game. Who else is in there? Oh, Olivia. Yeah. Yeah. There might be more, but none of the others talk. You know how it is. No, you guys talk more than any class. I have to shush you guys, actually. But for some reason, we always end up getting off topic. Maybe that's it. Period 5-6. You guys have not seen, I'll show the Burple commercial after this. And then you guys will be like, yeah. Then you guys will be like, oh yeah, the Burple thing. And that's how I know you guys aren't. No, I'm just kidding. All right, we ready for this? So I'm gonna add this manganese, manganese dioxide. Why can I use the same from period 5-6? Because it's a catalyst, I need more. There we go. A catalyst is not used up. Very good. So let's go ahead and put this in here. And I'm going to give that a nice stir. And I'm going to put this cap on here. Anybody want to tell me the decomposition of peroxide? Peroxide's H2O2. What does it form when it decomposes?
Hydrogen and oxygen gas.
They already beat you, actually. They like
I was
they
so
were
on top
they were already like 3 people beat you on that one. That darn mute button. Having to hit that mute button,
of it.
right?
I don't think that's-
They're saying no excuses. It's not the mute button. They just beat you outright. This class just got a lot cooler. You guys better watch out at home. They're throwing a little bit of shade. Yeah. They're giving you hints. You can press the space bar to unmute yourself.
I didn't know that.
So, all right, here we have fire. This is hard to do without being able to breathe on this. I don't know how the world's going to change birthday cake wise. But what I'm going to do is I'm going to try to get this out. Now watch this.
Oh, we seen it. One of the first videos we did of the guy that was like.
Is that because the oxygen's like resupplying the fuel?
Yeah, so oxygen on our planet is about 22%. If we had oxygen of 40%, you can see that it would be very hard to put out a fire, because if you have any embers at all, they will reignite. I don't know if I want to make sure that I have this so you guys can see it well. So if we put out the fire, that's a trick candle. If we put it on there, then we end up getting it reignited. So if the planet had a higher percentage of oxygen than 22, California wildfires would have probably destroyed the United States by now, right? It's continued going on. We would never be able to put them out, any forest fires and stuff like that. If it were less than that, then what? Yeah, it would be very difficult for us to breathe, right? We'd all be like, oh, not moving today. No, wrong. And as you can see, this is the reaction that she was doing. How hot is that? Yeah, it's hot. So there we go. Look at it.
Oh my God.
It's going crazy. Yeah. So that's pretty hot.
I don't know, it's just-
That's what I got for you guys today. Any questions at home?
What does it taste like?
What would that taste like? Have you ever actually smelled peroxide? Yeah, so some people actually, I think I've used it to gargle. You can do that. So then you know what it tastes like.
I forgot it.
Leo being Leo.
I meant like just punches on manganese.
He wants to know what the manganese dioxide tastes like. I would say like a rock.
Yeah.
Have you ever chewed on a rock?
Probably. I'm not gonna handle it.
Yeah, he's gonna plead the fifth on that one. If you guys have any questions, you're more than able to stay after, but I do want you to complete page 6 and 7, just those diagrams. Tomorrow is going to be a little rougher. We're going to have we're going to be dealing with maths, and that's going to require you to use your log functions possibly. Yay. So if you haven't done logs, that'll be a little fun thing. Bye.